All right, so first thing I want to talk about this morning is something that came up again. It's come up many times, and it will continue to come up because that's how life works, you know. Nothing new is under the sun. Isn't that right? Absolutely. Nothing's new under the sun. And that is accidentally overcharging a system. So why do you think a technician, let's just use yourself as an example. Why do you think you would accidentally overcharge a system? What would be the reason that you would do that?
I think the TXV's messed up, so I'm going to add some.
You think the TXV's...
I'm going to add like 4 pounds.
You're going to add like 4 pounds, see what happens? Yeah.
True story happened.
True story? You've done it before. Okay, all right. So you think the TXV, but why would adding charge help you decide if the TXV's messed up? You eliminate if it's low. Okay, interesting. All right, okay, fair enough. So what are some other reasons? What do you think the most common reasons somebody adds charge when charge is not what's needed? Bert. Sorry.
Low airflow.
Okay, low airflow, but we're jumping right to the cause. But what are they seeing? What are they seeing that's making them think, this sucker needs some Freon? All right, hold on, we're going to write it on the board. Needs a Lil... Oh, hold on, I spelled Lil wrong. Lil Freon.
Low suction pressure.
All right, there we go. Low suction pressure. Low suction pressure. So that's what I want to talk about, is low suction pressure. Because sometimes what I realize I do far too often.
You fart too often?
I do that. Yes, I do. And actually last night was an example of it. We had Christmas at the Clarabouts, and I was standing there, all the sisters were talking, and I was like way over in the corner, and I let a silent one rip that nobody could hear. And then all of a sudden, like 3 of them perk up their heads, and I'm, who did that? Was that you? But I was far enough away that I didn't get blamed, so that was good. That was good. Hopefully they don't watch this video. Anyway. Good one. Good one. My wife's like, what do you do for a living? All right, low suction pressure. And so what I realize sometimes is that I talk about this and that and the other thing, and all your eyes glaze over and you don't get anything out of the class. So what I want you to get out of the class today is why low suction pressure happens. I want you to come away knowing why that happens without a doubt in your mind. No doubt in my mind why low suction pressure happens, okay? So let's get some theories. What are some theories of why a system might have low suction pressure? Airflow. Okay, we're going to say low. We'll say low airflow, but low airflow where? Let's be very specific. Low airflow where? Over the evaporator coil. Over the evaporator. But let's see if we can think of a better way of saying that, because is low airflow actually the problem? Are you just trying to, Sam is whispering in your ear. He's whispering sweet nothings. So low load is actually what I like to say low load. That's a phrase I like to use, and like folks who do refrigeration like to use that. But I want you to come up with a better way of thinking about the term low load and what it means. So, Jesus. I was talking to Jesus over here.
Oh.
Jesus, what's another way you can think of to say low load? Not enough air going through the coil, okay. So, low airflow over the evaporator coil, I think that's close enough to that one. But are there other things? What is actually happening when air goes over the evaporator coil? What is happening to the refrigerant inside the coil? It's changing state, that is true. But what's causing it to change state?
The air.
The air, but what about the air is causing it to change state? It's the what? It's the heat. Okay, it's heat. Comes down to heat. So, not enough heat entering the coil. Not enough heat entering the coil, right? Ooh. Well, no, you just said it right. What did you just say? I want you to say it again. I liked it. Enthalpy. Enthalpy. What is enthalpy? Anybody want to try to tackle enthalpy?
Total heat.
Total heat. Yep.
I was going to say heat content.
Total heat content. And so our goal is to, that's why I gave out some of those super secret hats that nobody knows about. Our goal is delta H. Our goal is to change total enthalpy. That's what we're trying to do. Simply stated, we're trying to move heat around. Is that better? We're trying to move heat around. And so in order to get heat out of the house, we have to put it where? In where? In the evaporator coil, correct. So we're taking heat, we're putting it into the evaporator coil. If we're not putting enough heat into the evaporator coil, how does that show up in our symptom in our system? Shows up as low suction pressure. But more specifically, what's another thing we can call low suction pressure? There's another name that I want to call low suction pressure. Who said saturation?
Eli.
Eli.
Eli, go home.
Saturation, but there's even so saturation is kind of a fancy term. Who here would like to tackle what saturation means? Exactly. So, as much as I talk about saturation being the point at which liquid and vapor are at the same place at the same time, and the temperature that corresponds to that at a given pressure, that's not something that's easy for you to hold in your head, right? So let's make it simpler. We can call it suction pressure. We can call it suction saturation. But what's another thing we can call it? There's another term. They use it in refrigeration all the time.
That you can call low pressure?
That you can call the low pressure. You can call it evaporator temperature. Now, why can we call it evaporator temperature? Because it isn't actually evaporator temperature, right? We're generally on a split system. We're measuring our suction pressure outside at the condensing unit on the suction line. How on earth can we call that coil temperature? Anybody know?
Saturation.
Because when you take that temperature, when you take that pressure and you convert it to the saturation temperature, that is our coil temperature. So long as there's not some significant pressure difference in between the two, which generally there's not going to be. I mean, like 99.99% of the time, you're not going to have a significant pressure difference between your suction line and the pressure inside the evaporator coil. That make sense? And when we say coil temperature, we're talking about a specific point in the coil. What point in the coil are we talking about? I'm going to let you think about it till you get it. What part of the coil are we talking about? Evaporator coil. So, all right, let's start here. This is a crudely drawn triangle that is supposed to represent an evaporator coil. Where do we feed the liquid refrigerant into the evaporator coil? Feed it into the bottom, right? And that's kind of a misnomer to call it liquid refrigerant. It's actually flash gas, right? Because it goes in, there's a pressure drop at our metering device, right? Our metering device is the pressure dropper, and it goes into our evaporator coil, and then there's generally multiple rows, and it goes through, and then it comes out the top, and the top is what we call what? What do we call the line coming out of the top of the evaporator coil? Suction line, right? Cool. Call it the suction line. Now, which part of the evaporator coil is going to be the same as your suction saturation temperature? No, the first 80% or so. It's probably more than that, generally speaking, but we say that. So this part here, and it's the part that's full of boiling refrigerant. Right? Make sense? So that's what we can call this. We can say, when we see low suction pressure, here's how I want you to think of it. I don't want you to think of just some ambiguous pressure that you're supposed to hit because somebody told you you're supposed to hit it. Now we know that it needs to be above 32 degrees in air conditioning. Why? Because it'll freeze otherwise. But the answer is not when your suction pressure is too low to add refrigerant to it. I mean, it may be the end solution, but that's not what our brains should jump to. Here's what I want you to think. When you see low suction pressure that relates to a temperature, I want you to think, is that evaporator temperature correct? That's what I want you to think. And when you look at an evaporator temperature that is more than 35 degrees lower than the return temperature, that's when you can begin to think, my evaporator temperature is too low. But I don't want you to jump to, it's probably refrigerant. I want you to jump to, it's probably airflow. I want your initial impulse relating to low coil temperature, low evaporator coil temperature, to be that it's probably airflow. Not enough heat entering the coil. Right, that's even a better way of thinking of it. And there are multiple reasons why not enough heat could be entering the coil, but it could be airflow, right? And in many cases it is airflow. For example, could you have enough air moving over the coil, but the coil has all of its fins missing? Could you have an evaporator coil that has no fins on it, or the fins are all messed up? Absolutely. If you work in a really salt environment, a corrosive environment, you can get a case where the fins actually fall off. And this is a good way to imagine this. So could you have perfectly good airflow, meaning the airflow that it's designed to have, and still not get enough heat into the refrigerant? Absolutely. That's what would happen if you had an evaporator coil with no fins on it. So would your suction pressure or your coil temperature be low or high in that circumstance? It would be low, right? Because in order to have the proper suction pressure, i.e. coil temperature, you have to be getting heat into that coil, because if you're not, that pressure and temperature is just going to keep diving. The practice of adding a little refrigerant to see what it does is not something that I'm going to eradicate from the field, because in some cases it actually is a good practice. And I'm not going to argue with all the super techs out there who want to tell me it's not. But here's the problem. The problem is that some of you are doing it without using a scale. If you add a little refrigerant, say half a pound, with a scale, I'm fine with that. You're not going to hurt anything on most equipment that we work on by adding half a pound with a scale. What you are going to cause trouble with is when you're not using a scale and you just keep jacking it in.
Oh, it's only half a pound.
What's that?
It was only half a pound. They added about a pound?
What was only half a pound? Oh, I think it was only half a pound. I think it was only about a half a pound. Right. That's what the text says. That's what you say in your mind. I think it was only a half a pound. Now, I say this a lot, but if this is a practice that I can get you to change, it will make a really big difference for you, which is whenever you put refrigerant in, use a scale. If you're working on complicated equipment and you're really starting to get concerned about what's going on with it, especially when you have variable speed compression and it's acting weird, as my good friend Larry Dion used to always say, doing something weird. We love Larry. What? Yeah, absolutely. Absolutely. The challenge is that you run into this situation and you think to yourself, well, I'm just going to add a little, I'm just going to take a little out. The best bet at that point is to go ahead and pull it essentially all out and weigh it out. We have the advantage nowadays that, and I'm not telling you to waste refrigerant by any means, but 410A is not nearly as expensive as R22 once was, and the vast majority of what we work on is 410A. And so to take a system, especially under warranty, especially if we installed it, and pull the charge out just to see what's in it, how much weight is in it, makes a lot of sense. All right, that should be one of the first things that we do under those circumstances, when you've got something really weird going on, especially with variable speed equipment where the compressors can vary, condenser fan can vary, blower can vary. It can do a lot of things, and it can trick you, it can fool you. So two sides of this. Primarily, I'm wanting to say, weigh in refrigerant if you are going to add a little bit, but then secondarily, if you really feel like you're chasing your tail, go ahead and pull it out. You don't have to pull it all out. Don't pull it out to atmosphere. Just pull it out till you get down to 15, 20 psi so that you can see how much you have in it. Now, the question of whether you're going to take that refrigerant you just pulled out and put it right back in again really depends on the condition of your tank. Was it completely evacuated brand new tank before. If it was something that you've been using for a while, you wouldn't want to put that back in. Another thing that I'm wanting to get us to do, and I know this is maybe a couple steps away, is whenever you are recovering, use a nice big 3/8 flare filter dryer and then charge back through a filter dryer as well out of the tank, just to ensure you're not putting contaminated refrigerant, even if it's even if you know the tank was evacuated and brand new and you just pulled the refrigerant out, because those tanks can have sludge down in the bottom of them because they've been processed many, many times, right? You buying what I'm selling?
Sometimes you start putting it back and there's dye in it.
Yes.
It's sitting in the bottom of the tank.
Yeah, that also happens. So just a few things to think about there. But, go ahead.
So on this, because thinking to where I would have struggled with this in the field, most time it tended to be with two-stage equipment that I may not have realized was two-stage equipment,
Right.
or variable speed equipment that I may or may not have realized was variable speed equipment,
Yep.
or just variable speed equipment that I didn't see, because I saw a ton of single stage equipment because I worked on a ton of property managers, so I got really good at single stage. But every once in a while, I would come across something that I didn't quite understand.
Right.
And they do something weird,
Right.
comparatively speaking.
Right.
Now it's, as you become well versed with them, it starts to make sense. But the biggest thing with the two stage with the variable speed is, how do we test those?
Right.
How
So,
do we test those?
right. And what we're getting at here is that you have to be in high stage. You have to be in high stage. You have to be in the appropriate cooling airflow in order to properly test and charge a multi-stage piece of equipment. And that's a common mistake. If it's in low stage, now you're trying to charge it and you might be adding refrigerant to it and wondering what's going on. Or maybe your airflow's ramped down. Maybe you have a dehumidification mode on the equipment. And so airflow is ramped down and now you're trying to charge. But the main thing I'm wanting to cover, and just make sure that you get anchored in your head, is that when you see low suction pressure, stop thinking low suction pressure as if there's just some number you're supposed to hit. Instead, think that's my evaporator temperature. Now, heat entering the coil affects your evaporator temperature, how much heat is entering that coil, but then also the amount of refrigerant also does, right? So if you are starving your evaporator coil, if your metering device is underfeeding, or if you are significantly undercharged, that will also cause low evaporator temperature. But I don't want you to start there. I always want you to start by thinking, am I getting enough heat into this evaporator coil? Now, if you follow like our cheat chart with the colorful cheat chart that shows you, you're going to know pretty quick if you're also looking at suction temperature, you're also looking at superheat, you're going to know pretty quick whether or not it is an airflow problem or whether it's an underfeeding of the evaporator problem. So again, just to nail this down, low airflow, low load, not enough heat entering the coil, that's one category, and then underfeeding is the other category. And back to what Grant was saying, he added a little refrigerant to it, because he was wanting to see if maybe it was low on charge or maybe it was the metering device. But again, keep in mind, a TXV's job is to maintain the superheat. And the majority of what we work on nowadays are TXVs. That's the majority of the metering devices we work on. And so we're not charging to superheat. We're letting the TXV do its job. We're just charging to subcooling. So in terms of how we charge, it's gotten a lot simpler. If we know that we're in proper conditions, like today, obviously, it's cold enough outside that if you ran systems in cooling, you couldn't charge them properly unless you used a charging jacket or something else. But as long as you have proper conditions for running the system in cool mode, and as long as the system is on high stage, meaning it's ramped all the way up, then you charge by subcool. Pretty simple, right? But you do it with what? A scale. Because if you got a brand new piece of equipment that just went in and it comes with a factory charge of 14 pounds or whatever it is, and you've got a 40-foot line set and you're putting more than a pound in, you got to start thinking something else is going on. And primarily you want to start with low load, airflow, not enough heat entering the evaporator coil. That's where you want to start. On new installs, a really big thing that we need to be doing, we've talked about it before, is checking static pressure. I know we slide away from doing that. It's a very easy test to do. But even more importantly, the more common cause of airflow problems on new installs are actually how we set up the system. So if it's an infinity system, how are we programming the control? If it's it's kind of your standard FV, we're talking carrier model numbers here, but it's the same for pretty much every brand. You have your communicating super high-end equipment that you program from the controller, and then you have some versions that you program on the pins and the air handler. That's a common cause of problems. Or it's wired incorrectly. You've got your landing your Y wire on the wrong terminal, or you're not getting a call on your G terminal, like we talked about recently. If you don't get a call on your G terminal, your blower's not going to ramp up on a lot of variable speed equipment. Your DH terminal isn't wired properly, or your DHUM, or whatever brand you're working on. So those are all things that if I'm saying this and you're like, ooh, I don't know what he's talking about, that's okay, right? But now next time you go to one, you need to know before you leave. You can't just assume. You can't just say, like we often do, like techs often do, well, the airflow is fine. When you say the airflow is fine, Ronnie, have you ever said that before?
Nope.
Never. Yes, he has. If you say the airflow is fine, what do you think an average technician means by the airflow is fine?
The fan was running.
The fan was running, and they looked at stuff.
They looked at the filter, they looked at the return.
They looked at the return, they looked at the filter, they looked at the evaporator coil, right? And that's good. That's a really good place to start. In fact, I advocate for that. I am not somebody who thinks that you need to pull all the fanciest tools and start doing that right away. It's just mostly going to be a waste of time for the bulk of what we do. But after you do your visual inspection, the answer is not the airflow is fine. The answer is I did a visual inspection. The evaporator coil looked clean. The blower wheel looked clean. The filter was clean. But there's a lot more you don't know. Did you inspect all the ductwork, inch by inch? No, of course you didn't. Did you check the static pressure? Well, I hope so, but statistically speaking, the odds are you probably didn't. So that's the next step. Did you check all of the settings on the control board? Did you check the settings on the thermostat? Did you make sure all the wires were landed properly and that they were getting the proper calls for the mode? Were you ramped all the way up? And my point being that this is where you start. Like, I'm not being hyperbolic, I'm not exaggerating here. This is where you start before you say, well, the airflow is fine. Because very often we're adjusting charges, adding a little, taking a little out, when that's just a waste of time. It's just an airflow problem. It was just a heat load problem. It was just not enough heat entering the evaporator coil problem. And in terms of, like, you don't have to be a super tech who knows the entire rack manual front and back in order to know this. Start with your visual inspections. If you're a good visual inspecting, cleaning technician, that's a great start. That's where you do start if you've gotten thrown out there and stuck, right? Because a lot of us, that's how we learn the trade. But the next step is, now don't just go to adding and removing refrigerant. Go to understanding heat load in the evaporator coil, specifically airflow. And then the next step is, if you are going to add or take out a little charge, because there are cases that that's going to happen, just use a scale and use some common sense about how much you're putting in and taking out. And my just standard rule would be, if you're going to do the add a little, see what happens, add half a pound and see what happens. Don't add a pound, don't add 2 pounds, don't add 3 pounds.
4 pounds.
Or 4 pounds, or 6 pounds, or 23 pounds.
Like, I don't know why it's not going.
Or just keep loading tanks in it. Boss, I ran out of Freon on my truck. How much did you start with? Well, I only had 3 jugs of 22.
Just need one more, I think. That'll do it.
I mean, we've all seen it, and we've probably all done it, so I'm not making fun of people. I mean, I am kind of making fun of people, but I'm making fun of myself, too, because we've all done it. But
Overcharged was 7 pounds, and it was a damper system.
a zoning system, yep, one of the dampers was closed, or a bypass damper's open.
But I bet you completed a visual inspection. I did. You did. Filter, coil, it all was clean.
Yep,
It sounded like it was blowing from there.
Yep. I did one where instead of, because back in the day, we used to have all these zoning systems, all these old Honeywell Troll Temp systems, and they would have bypass dampers in them. And this one, I thought that I tied the bypass damper closed, but I actually tied it open, and it had a real low suction pressure. I had to keep putting Freon in that sucker, and she just wasn't coming up. So just remember that one of the primary factors that drive your coil temperature is how much heat is going into that coil. And the primary factor that drives how much heat is going into that coil is how much airflow is moving over the coil. Now, before you go too far the other way, because this is another mistake I did, you can have too much airflow. Like it's not like you just keep increasing airflow and that makes the system work better. All right, that's not what we want. We want around a 40-degree evaporator coil at 75-degree indoor temperature. That's a typical operating condition, a standard operating condition in our trade. And as soon as I say stuff like that, they're like, well, I always get it. Well, that's not true of all equipment. I understand that. I'm talking about residential, typical equipment in our market. That is generally what we want to see. A 40-degree suction saturation, a 40-degree evaporator temperature at 75-degree indoor temperature. And that tracks, right? Indoor temperature's higher, suction saturation is going to be higher. Evaporator coil temperature is going to be higher if it's lower. But if your airflow's off, then those two aren't going to match. If your airflow's too high, then your coil temperature is going to be higher than it should be, and you're not going to remove as much condensation as you should. You're not going to dehumidify as well as you should. Coil temperature's too low, system's not going to work as well as it should. It's not going to have the capacity. It's going to be prone to freezing. Right? Make sense? Does everybody get that? What I'm trying to hammer here? The other side of it is, we're going to talk about this in a future class, is thinking about condensing temperature rather than head pressure. Same sort of thing, but on the other side. But if you start using a scale, a lot of these problems will go away. You're going to catch yourself. You'll check yourself before you wreck yourself. Sorry, I had to say it. That's how it goes. Any questions?
What about low heat across the evaporator this time of year with installs and service?
Because of load conditions, right. Okay, so yeah, that's a good point. If you're going to go out and you're going to start a piece of equipment today, you need to check it in heat mode. Pretty much every piece of equipment is going to have a heat mode check guideline, and if you're installing a new piece of equipment, you need to follow that guideline. I have a whole set of rules of thumb that are great for service technicians working on older equipment, but for newer equipment, look at the heat check guideline. The manufacturer that you're installing, what it says. I can see some eyes there like, well, I don't think there is one, whatever.
Well, wait.
Check.
You want to weigh it in and then confirm.
Correct.
With your
Start by weighing it in, the length of your line set, all that. And mostly we don't have to make, these are not significant changes on a brand new piece of equipment. You're going to check it in cool just enough to make sure that it runs in cool. You're not going to run it for 20 minutes. You're going to run it for 5 minutes and just make sure it runs in cool. And then you're going to run it in heat and use the heat check chart. And that's when it's 65 degrees outdoor ambient or lower. That's pretty standard. Some brands are slightly different, but
and they're all on the panel on the carrier.
Yep, so follow what the panel says. That's that. Does that answer the question?
Yep.
Great.
You do have a lot of people adding charge this time of year because they're just not used to seeing these low pressures.
Yep. And again, in terms of things that you should have a backup of, a scale is a pretty big one. Like, a scale is something I don't want you to go without. A scale is something I don't want you to say, hey, where's your scale? Oh, well, I loaned it to somebody. When? Oh, I don't know, a couple months ago, whatever, right? It's like a micron gauge in that regard. You remember how much of this we went through with micron gauges when I really first started making sure you were using them. Just like, well, it's somewhere in here, someplace, kind of a thing. I want you to have a scale, keep extra batteries, maybe get an analog scale just as a backup in case you're out of I don't care. Just come up with a system so that way you always have a scale that you can rely on. And again, scales, depending on the ground that you're on and how level it is, it's not like you're going to be always perfect to the ounce. I'm not worried about that for most of what we do. I'm worried that you're not putting 4 pounds in of a piece of equipment that doesn't need 4 pounds added to it. That's what I'm concerned about. It's a waste. I mean, the fact is we're going to make it right to the customer if we ever catch it, but it's just very wasteful and you're making equipment not work well. So don't do that. All right, that's it.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.